The James Webb Space Telescope has been sending images to Earth since July 2022 and has already delivered a startling finding, seeing galaxies orders of magnitude brighter in the early universe than astronomers had anticipated. The Webb telescope was designed to see deeper into the infrared spectrum of light than the Hubble Space Telescope. Infrared light does not get as scattered by dust and filament clouds as does the visible light spectrum. Consequently, photographs of deep space using the infrared spectrum reveals many more stars hiding in the haze of outer space. Additionally, there is the redshift factor. The older the galaxy, the faster it is moving away from us, making the Doppler effect on the light waves coming from deep space stronger the faster the receding velocity. The Doppler effect is familiar to us in the change of pitch of a train's horn as it passes by. As the train moves away from us, the sound waves are stretched out, making the horn's tone lower. In the case of light, the Doppler effect lowers the received light frequency towards the red end of the visible spectrum, and if pronounced enough, into the invisible infrared part of the spectrum. In order to photograph galaxies that are so old that the redshift has moved the visible light wave spectral lines into the infrared range, the telescope's mirror and imaging chips are engineered to be sensitive to red light in ranges our eyes can't see. In the standard model of cosmology, evolutionary cosmologists say the first stars formed 400 million years after the so-called Big Bang, and the first galaxies then formed a few hundred million years later. High redshift values are a measure of the age of a galaxy, and the degree of shift that the Webb telescope is showing implies that the galaxies existed 180 million years or less after the Big Bang, in clear violation of the theory. A galaxy of 180 million years old is considered young in a universe believed to be over 13 billion years old. Following Webb's findings of surprisingly mature galaxies located in a very young part of the universe, theorists and observers have been scrambling to explain them. Reaching back to a comparatively young 180 million years after the theoretical Big Bang, the telescope found some galaxies with large, fully formed disk-like structures that were not expected to exist so early in cosmic history. Stacy McGough, cosmologist, Case Western Reserve University, was quoted in the September 14, 2022 Scientific American saying, "We should see lots of these little proto-galactic fragments that have not yet merged to make a big galaxy. Instead, we're seeing a few things that are already big galaxies." Early proto-galaxies are expected to be small, dim, and thinly populated fuzzy blobs of stars, but what is seen are fully formed and evolved galaxies, well-defined with spiral arms and many times the size and energy of our Milky Way galaxy. The Einsteinian gravity-fed standard model of the universe's evolution is falling under the wheels of increasing observational resolution factors, greater levels of detail, from which to extract predictive patterns. This is science in action, doing what it is supposed to do: make new discoveries, not validate old ideas. This is the Platonic underpinning of scientific method, the replacement of old hypotheses by new and better ones. When science refuses to be updated, it ceases to be science and begins to resemble an authoritarian cult, a collection of fetishes. Mainstream astronomers, instead of being excited about new discovery, act like they were caught flat-footed and not at all happy about a $10 billion investment that appears to have paid off. When Michael Boylan Colchin, theoretical astrophysicist, University of Texas, Austin, said in Science Journal, 12 August 2022, "No one was expecting anything like this. One can only ask, why the heck not? The entire point of science is to toss obsolete ideas into the dustbin of history. This is precisely what scientists should be prepared to expect. It is unsure whether current galaxy formation models need a revision or abandonment. One can only marvel at the kludging of band-aid concepts to paper over observations that were unexpected. The evocation of dark matter and dark energy in the face of the failure of Einsteinian empty space to account for the high rotational speeds of galaxies seems more like a parlor conjurer's rabbit-in-the-hat trick than a science eager for a better understanding, even if it dynamites cherished canards like the Big Bang Theory and black holes. Models hold that gas clouds should be far slower to coalesce into stars and galaxies than is suggested by the Webb's galaxy-rich images of the early universe, less than 500 million years after the Big Bang. In questioning the validity of Big Bang, Paul J. Steinhardt, professor of physics, director of the Princeton Center for Theoretical Science, in Scientific American, September 28, 2017, calls for reconsideration of the cosmic inflation theory, or Big Bang as it has come to be known. He states, "The cosmology community has not taken a cold, honest look at the Big Bang inflationary theory, or paid significant attention to critics who question whether inflation happened." But even before the experts could start incorporating the Webb telescope data into their interpretive frameworks, when the first Webb telescope pictures were only days old, astronomers from the University of Edinburgh and Scotland announced that they had found a galaxy with the incredible value of 17Z. That value would indicate that this galaxy had a redshift of 17Z, which would mean this galaxy existed only 220 million years after the Big Bang. The galaxy, Sears 1749, but popularly called Schrödinger's galaxy, shows, in addition to its unusual age, a huge mass, which means that there are a lot of stars in the galaxy. So the oldest galaxy in the universe is anything but a small cluster of stars that might have formed shortly after the Big Bang. With 5 billion solar masses, Schrödinger's galaxy is about 5 times more massive than our Milky Way. Schrödinger's also exhibits an enormous luminosity. The galaxy brightness is much too high for one that existed only 220 million years after the Big Bang. Tommaso Tro, professor of physics, UC Santa Barbara, echoes the consensus of consternation when he said in the October 2022 Astrophysical Journal Letters, "Somehow the universe has managed to form galaxies faster and earlier than we thought." The Webb telescope images from NASA also unexpectedly reveal for the first time barred spiral galaxies located at a time when the universe was a mere 25% of its present age. Barred spiral galaxies, similar to our Milky Way, are considered to be a mature, not a young galaxy type. In fact, to have evolved from normal spiral galaxies, making them older and more evolved galaxy type. Garth Illingworth, professor of astronomy and astrophysics, UC Santa Cruz, in the 9 August 2022 issue of Science Journal, exclaims, "This is way outside the box of what models were predicting." One can only hope that the new box Illingworth and his colleagues are busily constructing will be one capable of expansion. It will be interesting to see how the engine of orthodoxy integrates this new data, which is very recent and not fully metabolized by the ivory tower. Whatever the outcome, it is certain that the cosmological discourse will gravitate away from Einstein's space is empty gravity model. Since that hypothesis has been defended for decades as unquestionable truth by the vast majority of cosmological theorists, the new data is causing these theorists to panic. Based on the published literature, right now the Big Bang makes 15 wrong predictions and only one right one: the abundance of deuterium, an isotope of hydrogen. In the 27 July 2022 Nature Journal, Alison Kirkpatrick, assistant professor, Department of Physics and Astronomy, University of Kansas Lawrence, appears to be not having much luck wrapping her head around the new Webb data. Quote, "Right now I find myself lying awake at 3 in the morning and wondering if everything I've done is wrong." Dr. Sabine Hossenfelder, research fellow, Frankfurt Institute for Advanced Studies, has been wondering the same thing even before the Webb data entered the fray in this panel discussion from 2021, sponsored by the Institute of Art and Ideas.
And that's exactly what I mean when I say we have a problem with theory development. Because you have all these theorists, they literally guess their models. And it just leads nowhere. And I really think that theoretical physicists, they have to have a hard look at their methods of theory development and throw out what didn't work. We talk about the scientific method as if it was a fixed thing, but it's a living and evolving thing. And what counts as good science at one point in the history might no longer count as good science 100 years later.
Dr. Hosenfelder is an example of a scientist doing what they should all be doing, protecting the scientific method and its process of hypothesis formation. Will this predictive failure of the accepted cosmology reinvigorate discussion towards alternative cosmologies? What I mean specifically are the steady-state theories of William Duncan Macmillan, Herman Bondi, Thomas Gold, and Fred Hoyle, and of course the electric universe model of Walt Thornhill, Don Scott, Dave Talbot, Ev Cochran, Eduardo Cardona, Michael Armstrong, and Mel Acheson, to name a few. Perhaps a cosmology of the future is already here, although not yet acknowledged in the mainstream. The field is entirely wide open for those curious enough to invest the energy to think. The EU model of cosmology represents a change in the categories of astrophysics, and most important, the methodology of thought which must drill these new ideas into the lockstep mind of conventional science.